name is Kevin. I'll take you through this tutorial on DNS. The agenda is what you see there. We're going to do an introduction to DNS, which will be slides. Then we're going to do a short lab, and then we're going to do a bit of command line interrogation of DNS. The goals of this tutorial are to explain the fundamentals of DNS, make sure that you understand how it works. We're going to do a small lab that shows you how to set up a simple DNS server. And then we're going to do command line interrogation of DNS. And then this is also an opportunity to test this lab, see how it works, because in future we may use this lab for other workshops like this, or maybe others that someone else will be leading. In future, depending on how this is found useful by the community, we could do more exploration into DNS. DNS is a very broad topic. So there is authoritative DNS and extended DNS, which I'll mention, which are also options. So I'll start with the fundamentals. These slides are adapted from those used at AFNOG. AFNOG is an annual workshop which covers training for engineers in different backgrounds, different tracks. I've trained there as well as a number of the KeNOG PC. So we often refer to those slides when training. So this DNS tutorial, it's shortened. Usually the one we do at AFNOG is about 6 hours or so. But of course, I've trimmed it down just to focus on what we need to cover for the 1.5 hours that we're going to do. Okay, so we can start. If you have any questions, you can put in the chat or just unmute yourself and ask, because I can't really see where the chat goes here when we start. I think we all know why we need IP addresses, or rather why we need DNS. It's because there are millions of devices on the internet, and as human beings, we cannot remember all those numbers. For example, I can remember all of the names of the people who will be on the call today, but I might not necessarily recall all of your phone numbers. And that's why DNS is very important. Another very important reason why we need DNS is because even though you can store name information, so even though, let's say, you can remember number information, like you can remember someone's number, that person may change their phone number. And in DNS, if that happens, it means that computer has changed its IP address for a number of reasons. Maybe you've moved to a new ISP, or it's been necessary for you to change IP addresses. How do you update everyone else who needs to contact that server or that service? And that's why we use DNS. In the old days of DNS, there was one single file. It was called the hosts.txt file. And it was managed by one individual who was keeping track of all those names and numbers, name to number information. And this did not scale very well for a number of reasons. Over time, as the internet continued to grow, this file became very big. There were several collisions. So, for example, I'm in Kenya. I'll say I want kevin.com. Someone else would be in another country, say I also want kevin.com. So that's a name collision. Which one is the real kevin.com or kevin.net or so on? Consistency and also keeping it up to date with the information. You'd have to find a way to contact the individual managing this to update it. Single point of administration. And of course, for all these reasons, it just did not scale, because as we know now, the internet has millions of devices connected. So DNS was born, and simply explained, it's a distributed database for holding name to IP address and other information. It started with simple name to IP address, but it expanded to much, much more. And we are going to see, how different types of data are stored on DNS. It's distributed, meaning there's no single point of failure. There's no single administrative entity that manages DNS. It's broken up in different parts of DNS are managed by different entities. It's quite robust, especially these days. There's a lot of redundancy built into DNS, a lot of replication, caching, which we're going to talk about, and it's a client-server architecture, which is now a critical part of the internet. In fact, without DNS, it would be very difficult to find your way around on the internet. So DNS is described as hierarchical. What that means is it follows like a root and tree structure, as you can see there. Everything starts with the root. As I was saying, DNS is hierarchical. You can see, how DNS is structured. They are very similar to the Unix file system if you're familiar with how the DNS is structured. And the reason this is put in place is because different parts of this DNS structure can be managed by a different organization. So, .com can be managed by one person, and then Yahoo.com can be administered by someone else, and that's the same whether you're looking at .com or .ke. So .ke, as you may know, is managed by KeNOG, or the Kenya Network Information Center, and then different parts of that can be controlled by someone else. So there's nog.ke, which we use as KeNOG. You may have your own company.ke, which you also manage, or you delegate to your ISP to manage. So DNS is described as hierarchical. They are globally unique names. It's administered in zones or part of the tree, as you've seen. You can give away or delegate part of the tree underneath you. So for example, let's say you have a domain there that we're calling 1234.0.ke. You can delegate part of this 1234.0.ke to someone to manage, and then break it up so that maybe finance.1234.0.ke is controlled by a different entity, and so on and so on. And by doing this, yes, it may sound a bit more complex, but it does build in a bit of resiliency and redundancy, so that not one single point of failure will result in DNS being unreachable, you being totally unreachable, so to speak. So domain names are, not really unlimited, but you can add a lot of information in DNS. There are documents called RFCs, or requests for comments, that specify what you can do in DNS, what you can include, what you need to exclude. You can all look at those RFCs and see some of the the rules of how to manage DNS and how you can control what's in your domain name. So for example, you cannot have an underscore in your domain name. It cannot be something like Kevin_com.co.ke or something like that. That won't work. So there are some RFCs there which you can have a look at, and these RFCs are updated all the time. But when you Google an RFC or a request for comment, to tell you, this document has been is obsolete, or has been obsoleted by another RFC. So when you're using DNS, you'll need to input some information, which is called a key, in order to find the IP address. And this is called a resource record. And what a resource record does is, or what it is it's a store of a specific type of information. So you can request DNS to give you a specific type of record. And there are very many types of records you can request from DNS. What you're going to see here on this slide is the most commonly used, or the most commonly that you're going to refer to. So I'll start with the first one, which is an A record, or an address record. An address record simply maps a host name or a name to an IP address, and we're going to see how that works, or an IPv4 address to be specific. The quad A address does the same thing, but then outputs an IPv6 address. Pointer record, or PTR record, you can think of this as an opposite, or the opposite of an A record. It maps an IP address to a host name. So if you're given an IP address and you're asked to find the host name, what you'd ask for is, give me the pointer record, or PTR record for that domain or host name. Then you have your mail exchanger record, very important record, which some of you who are managing DNS, maybe you've interacted with. It stores information related to which servers are to receive email for a domain. And there's a lot of, there are many records associated with email. This is one of them. But a lot of these, before you can get your email going, you really need to have a number of these in place. For example, you need your pointer record in place, you need your A record in place, you're going to need some form of TXT record. And as time goes, more and more information is being added, which relates to how you manage your email. And this is because to combat spam, you have to use a lot of techniques, and a lot of those techniques are built into DNS. Another type of record is the TXT record. Sorry, I've skipped the one. Is a CNAME record or a canonical name. This is an alias record, or you can call it like a nickname record, sort of, which you can say if someone types www.nog.ke, it will be the same as saying nog.ke. So when I go to a browser and type nog.ke or www.nog.ke, I'll be directed to the same online resource by using a CNAME. So a CNAME is like an alias or a nickname or another name you can use for another record. TXT record, you can put any type of information in this TXT record. You can put some description about your domain or your zone. You can put information related to your email information. You can put other things that, any type of text information that you'd like to have on your attached to your domain. Then you have your name server records, which specify your start of authority. We are going to talk about authoritative DNSs a bit, but just know that name server records store the servers that are authoritative for that domain, or servers that will answer on behalf of that domain. There's a URL there which I'll put on the chat for you guys to have a look, because you have several types of records there, which you'll see. I've just mentioned the main ones. Let me just dump it here. So I've mentioned the main ones, but you can go there and see that there are several types of records out there. And depending on what type of information you're trying to find, you will request for a specific type of domain name or specific type of resource record rather. So a simple example, if you query www.nog.ke and you ask for an A record or an address record, you'll simply get the IP address information that, as the answer. We're going to see more about what this answer is structured like. This is what we call a time to live. This is the class of information that is requested, and this is an A record, the resource record type. In this single case, a single RR is found or a single resource record is found, but there, sometimes you may, depending on how the owner of the domain has structured his domain, you may be able to get more than one type of answer when you ask, and we are going to see that. In the class for internet use of the DNS, so this information here stands for internet class, meaning the information being requested for is, can be used on the internet or online on the internet as we know it. When the internet was being designed long ago, it was not, there were several competing technologies or, network infrastructures. So what they did, they built into DNS a way to specify where that record would be used. So this could be switched, but of course we're now using the internet globally. When you request when you request for a resource record from DNS, you can get several types of answers, and we're going to see this shortly. You can get a positive answer or a no error. This means that the information you asked for is available and there is an answer available. If you ask for a domain that does not exist or a resource record that does not exist, for example, abcdxyz.com, you will get an NX domain. It's a domain that does not exist. So your DNS server will respond that you've asked for something that doesn't exist. You could get a server failure day, which means whoever is in charge of the DNS server maybe has not configured it properly, it's not working well. You can get a format error, which means the way you've requested the information was incorrect, and you need to specify that request again. Or you can get a refused answer. A refused answer basically means you're not allowed to use that DNS server. There are DNS servers that are restricted, and you can't really use them. So for example, the DNS servers you will set up in this lab will be restricted to a certain IP address block that to use it. So you're going to see how to configure that. One important record that we're also going to discuss is the pointer record or the PTR record. If you're managing emails, this is a very important record for you, and also something you're going to need to configure if you're interested in doing your own email. What this does is give a host name from an IP address. So if you're just given an IP address, how do you find out the associated host name for that device? So you look up something called a PTR record, and this is also known as doing a reverse DNS record or a reverse DNS lookup. And we are going to see that on the command line shortly. So I'm going to stop here and see if there are any questions so far. I'll also keep tab on the time. Do you have any questions? Anything you'd like me to go over? And apologies, I did not notice my screen was not shared at the time, but let me know if you'd like me to go over something else. Okay, no question. Okay, do I see something in the chat? Yeah, thanks, everyone. Okay, so let's go through the different roles in DNS. So when it comes to DNS, there are three main roles. The first role is called a stub resolver. The second role is called a caching resolver. And the third one is called an authoritative name server. Now, these three roles in DNS are played by different parts of the internet system, but also your computer. A stub resolver takes a request from an application, for example, a browser, formats it into a UDP packet and sends it to a recursive resolver. Your recursive resolver is actually the service on the or the server on the internet that tries to obtain the resource record information that you've asked for. So when you go to your browser on your mobile phone and you type facebook.com or yahoo.com, there's a stub resolver in your phone or in your device. It takes that request from your browser, packages it, and then sends that request to a recursive resolver, or what you guys will actually know as the DNS server. Recursive resolver is actually the DNS server that you're going to configure. What the DNS server does is that it goes on the internet, checks for the information you've asked for. So you've asked for, let's say you've asked for an A record or an MX record, gets that information and then sends it back to the application that requested it. Sends it back to the application that requested for that resource record. Now, the DNS servers can also be caching. And what that caching word means is, as people use that DNS server, as you make more and more requests, it will store the popular requests on the hard disk so that next time it doesn't have to go to the internet and take more time to get the answer. Finally, we have what are called authoritative name servers. These are servers that are responsible for a certain domain or a certain zone, and they only provide, they only give a specific answer. So to give you an example, if you go and ask an authoritative name server for information regarding www.kenig.org.ke, it will only answer if it is the authoritative name server for that zone or that domain. And we're going to see that application on the command line shortly. So DNS is a client-server application. You make a request and then a server is going to respond. DNS can also use TCP, and we're going to see why. But traditionally it's used UDP port 53. But it uses TCP for large responses, or if the client has requested a response in TCP. And these days your applications are very smart. If they don't get a response on UDP, they'll also try on TCP. Because sometimes if there's rate limiting or something blocking UDP traffic, they'll also try TCP. Now, when you're doing DNS, as I said, traditionally, especially when I was in working in my previous job and I was just getting into this, it was only UDP at that time. And most of the servers that you'd work with who don't respond on UDP. But these days, because of extended DNS, because of stuff like DNSSEC, and because of the need to include more information in the DNS response, your software, whether it's on your computer or your DNS server, it will be able to respond on both TCP or UDP, or at least have that capability to do so. You can go to that URL there that specifies the RFC that talks about UDP versus TCP and when or where it will be used. It's interesting information to know. Normally, you probably wouldn't care about this. You just want to get online. So this is mostly for those who manage like a DNS service. So very briefly, the stub resolver, this is probably something you not interact with very much, but it's just a piece of software built in your device, whether it's a mobile phone, a computer, whatever it is. It's going to have some sort of stub resolver inside. It's configured, and as I said, it takes the request from the application. It could be a browser, could be an email client, asking for information. It will package that information properly and then send it to the DNS resolver, which you're going to see shortly. You have to configure this information manually on your computer. So some of you may have already configured your stub resolver, just didn't know what you're actually configuring. When you're on Windows and you're configuring the IP addresses, you're just configuring the stub resolver, what it's going to access. If you're on Unix, you've probably come across etcresolve.conf. You've either done it manually or that information has been received on DHCP or via DHCP rather. For you to use a DNS server, you must have permission to use it, preferably something that is nearby, something that is close to you as an internet user, and something reliable. If you have faulty DNS, you're going to have a very poor internet experience. I often say it doesn't matter how much speed you're provided, even if you're given 100 Bps, 1 gigabit per second internet connectivity. If you have a poor DNS server, you're going to have a poor service because it basically means whatever you're looking for on the internet, you won't be able to find it. So this is how you configure your stub resolvers. So on the left there, you see the Unix way of doing it. You'll configure your a file there called etcresolve.conf. If you're on Windows, I believe this is how it's still done. And you can go to network preferences and somewhere you'll find a window like this. And then you'll put in your preferred DNS servers. The DNS server has to be an IP address. It cannot be a host name. It cannot be a host name because the computer doesn't know what to resolve. So you have to provide an IP address. And that's why if you look at the Windows option on the left, it doesn't give you an option to type a character like alphabetical characters, because you can't put a name, it has to be a number. I'm going to see if there are any questions so far about the stub resolver before we go to the DNS resolver operation, which is now sort of the key of this. Do you have any questions or comments here?
We don't have any questions yet on the chat.
Okay, cool. Good. Okay, so then we can go to the DNS resolver operation. So let's look at the resolver, how resolvers work. So your stub resolver, you've configured your operating system, or your mobile phone has received this information via DHCP, and it knows which DNS server, which resolver it's going to use. It's going to send a query and say, for example, give me the IP address of facebook.com, yahoo.com. The resolver is going to give it back an answer, and then your application can find whatever it is looking for. So if it's a browser, it will be able to open the web page. If it's an email server, it will be able to get the MX records and so on. So that's what happens if the information is in the cache. But as we've seen, let's say you just set up a new DNS server, there's nothing in the cache, it's empty. So you will need to, your DNS resolver will need to go out on the internet, get the answer that it needs, and then send it back to you. And to do that, it needs to query a number of authoritative name servers. So we start with the stub resolver. It's asked for information. For example, give me the IP address for facebook.com or yahoo.com or whatever. Your resolver will check the cache, and if it's not in the cache, it will go and find the information from the authoritative name servers, and it has to start at what's called the DNS root, and I'll talk about the DNS root a bit later. If the first name server it requests information does not have the specific resource record, that name server may say something like, okay, you have asked for facebook.com, I don't have that IP address, but I know another server down the line that may be able to give you that specific resource record that you're looking for. And what you see specified in number 2 and number 3 are what are called referrals. And basically what's happening here is the name servers on the internet that have been requested this information have given an answer that I don't have the exact resource record that you're asking for, but I do know someone you can go and ask. So this is like asking for directions, and someone says, okay, I don't know how to get there, but go ask this other person, they may be able to tell you how to get to where you're going. Finally, your caching resolver, or your, let's just call it the DNS server, will get the answer from the correct authoritative name server and then give it back to your stub resolver to send it back to whatever application requested it. So this goes on in the background when you're using your mobile phone or your computer or device, but it's good to know, the workings of that, communication. So it starts in a sort of hierarchical fashion. It will start at what's called the DNS root. The root is denoted by a dot or a full stop. Actually, when you type on your browser, when you type www.kenig.org.ke on a web browser, or you type www.nog.ke on a browser, there is an invisible dot at the very end. And that dot is what's called, that's the start of the root. Okay, so you don't necessarily have to type it, but your application will probably already know what to do and start, and definitely your DNS resolver will know how to start the queries. So to start with the DNS root, the DNS root will give a referral, say, I don't have that information for www.kenig.org.ke, go and ask the guys who are in charge of .ke. .ke may give another referral and say, I don't have the answer, go ask the guys who are in charge of .org.ke. And then finally, you'll be directed to the KeNOG.org.ke, and then that's where you'll get your actual resource record or IP address that you're seeking. So this mechanism of jumping from one server to another server is called a referral. You'll either get an answer or moved one level down. And once you install your DNS information, you're going to see how that works out. Just looking at the time. So when you are working with DNS, as I mentioned, you could get several types of answers. The server you ask could say, you've asked for a non-existent domain, you could get a server failed, you could get refused. Several things could be wrong. Rarely is that the fault of the domain server. Maybe it's more likely whoever has configured that domain. So I'm going to explain how your DNS software knows where to start. Like, how does it know which IP address of the root server to actually query? So when you configure your DNS servers, especially stuff like bind comes with this text file, which you can see. There's a file which is called a seed file, which contains information about the 13 root servers that are available on the internet today. So we have a total of 13 root servers. They have all of them have IPv4 addresses. Some of them have both IPv4 and IPv6 addresses. Your DNS software must know that information. And as we said, it has to be a file stored on the computer itself that it can interrogate. If you go to that URL there, ftp.internet.net/domain-name.cache, you'll be able to see what that file looks like. It's a very simple text file. It's worth checking every 6 months or so. And what it does, it just stores information about the DNS root servers that are available on the internet. So there are 13 of them. I won't get into a lot of details of the RFCs behind that, but I'll say that there are 13 because when the standards behind DNS were being formed, the UDP packet limit was 512 bytes, and it was not possible to add like 13 or 14, more than 13 name servers on the internet system. However, even though there are 13 of them, there are several copies or instances of those 13 name servers. We even have instances right here in Kenya, in Nairobi. I believe maybe someone on the call is managing one of them. You can go to those URLs and find more information about those root servers. But the key thing for you to understand is that there are 13 of them. Most, if not all, DNS queries that you will do on your internet will start at the root system, unless your DNS server has already cached that information or cached that request that you're looking for. Now, there are several types of softwares you can configure to manage or to provide a DNS service in your office or in your home. And there's a URL there which I'm going to share in the chat shortly. But the key thing to note is you can pick, maybe I should just share this URL in the chat so that you can see. So that's from Wikipedia. There are several sort of softwares you can use to configure as a DNS server. It's really up to you and your preference. We're going to use one that's called Unbound. It is very simple to configure. It's lightweight, and it doesn't have a lot of config that you need to do. But if you go to that website, you can see you have a choice of several to use. Now, for a small office or your home network connectivity, you don't need a big server to provide a DNS service for you. Many people just run DNS services as a virtual machine or even as a very small, running on small hardware like a Raspberry Pi, for example. You don't need a lot of RAM these days to manage it. Something with 512 MB or equivalent should be able to run a DNS server very easily, even less. So What we're going to do now, we're going to jump to a short exercise. Unless there are any questions, you can post any questions before we go to the lab exercise. What we're going to cover in the lab exercise is a simple DNS configuration. It's very simple DNS setup that you can do in your networks back home. I assume everyone on the call got the URL for the lab. Did you get your were you able to log into your DNS server? Maybe I should ask who was not able to access the DNS server.
Kennedy, Kevin.
Yeah.
There's a question from Cynthia.
Yeah.
Who asks, when you mention the resolver, do you mean the recursive resolver or?
Okay. So when I say resolver, as I mentioned, you have sort of several types of resolvers. You have your stub resolver, and then you have your DNS resolver. The stub resolver is what is already on your operating system, whether it's a mobile phone or a computer service, or a computer rather. And then what you're going to configure on that, and you have to do it on all your devices, is configure it and say, if you want to find an IP address or find a resource record on the internet, go and ask that recursive resolver or DNS resolver that is on the internet. So if I go back to, can you guys see my screen now, or can you see my desktop?
We can see you.
Yes, we can see your desktop.
Okay. So let me just, so it's a good question. Let me just go back to this and explain. So the stub resolver will be sitting on your computer, okay? And all it needs to know is the IP address of the DNS resolver. This one that I'm just calling resolver here is the DNS resolver. The DNS resolver is the one which I was explaining here. This one will go out to the internet and find the IP address or the resource record that you have requested. So more often than not, let me go back to this one. To configure your stub resolver, this is all you need to do, okay? And as I mentioned, you don't even need to do this statically, because this is already done for you in DHCP in several areas. And unless you specifically want to use another type of DNS server. All you're doing here is saying, if an application tries to get a resource record, it should go and ask this DNS resolver or cache server. So let me clarify the names. And depending on who's doing the training, you may hear the different names. When you hear the name DNS server, caching server, recursive server, resolving DNS, they all mean this one here. They all mean this one, the one that's going to go to the internet and find the IP address for you and give you an answer. Does that make sense, Cynthia?
Yes, it does. Thanks.
Okay. Yeah. So I think for the purposes of this tutorial, anytime I say DNS resolver, I'm talking about this server here that's going to go out on the internet, find the information you've asked for, and give you an answer. And that's what we're going to install in the lab shortly. Okay, so I assume everyone here got access to your labs. Were you able to get to the lab URL and login? Anyone not able to log in? If you had registered as per 1:30 p.m., I created all those VMs. Was everyone here able to log in? Because that's what we're going to use now. Yes. Okay, good. So I wasn't here at the time. Okay, so Anthony, what you can try, go to, if you know your email address, you'll go to this URL. Maybe I should dump the instructions here. Anthony, have you registered by 1:30 p.m. today? So as Anthony sorts out whether he had registered, you guys can go to this exercise. Let me just take you through the exercise. You can all go to this URL. Okay, so Anthony, I'll give you a URL to use shortly. So let's all go to this URL. There's a very short exercise I have prepared there. And I realize some of you may not be, maybe have used Unix or Linux command line, but it's very simple copy and paste. So once you're able to log into your server, you're going to type this command. Anything that starts with the $sign explains that you're supposed to run that on the command line, okay? So you'll type this on the command line and then you can just copy and paste. So for example, you can open this and then go here and type and copy and paste. The username and password will be KeNOG. Sorry, I changed mine. Okay, so all of the commands you see here, you can just copy and paste to save time. You don't have to type them by hand. So try the exercise, just copy the commands as you see them. And when you get to this section here of configuring the unbound file, this is the only one that you'll need to be a bit more careful because you don't want to make a mistake here. Once you install Unbound, you're going to need to run this command so that it does a bit of auto configuration for you. And then these two commands are for you to understand the IP addresses that you have in the lab. So the VM that you have, the virtual machine that you have, has two network interfaces. And this is to sort of simulate what would be in your home network or office network. So there's an interface that is facing the LAN, that would be EM0. So this is what you want to provide to your users in the network. And then there's a localhost interface, which would be for the device itself, or the operating system itself, the server itself. So once you're done with that install, I'm hoping, okay, that's fine, Stephanie. I'll type this on I'll do this step by step so that you can also see. But for the rest, you can go to this URL and start going with the exercise. Then it should not take you more than 10 minutes. So if we say by 5 minutes to 3, we are done, it should not take you more than 3 minutes to finish this. Okay. There's a gentleman who said it doesn't have a VM.
Sam and yeah, Sam and
let me see if I can provide a VM to you. And if you have any, yeah.
Oh, can the other guys start doing the lab? Or?
Yeah, please get going with the lab. Please get going with the lab. Just one moment. So, Sam and Anthony, I'm trying to see if we can get you a VM that you can use. For those who don't have VMs, I think just follow on the, I think we'll just follow, I'll run all these steps on the screen so that you can see, because I don't think there'll be enough time to spin up the VMs and give you guys access, because I need a bit more time to set up. So I hope everyone else is going with the lab. I'll start doing it here as well so that you can just follow what I'm doing. Sorry, that's my phone. Is the text clear? I should add more. I should increase the font. Is it clear?
Yeah, I think
Yeah.
you can. It's clear. It's clear.
Yes.
Okay.
I think it's like
Yeah.
that's better actually.
Okay, fine. So for those of you who have the lab, you can, if you have access to your lab, you can continue. For those who don't have labs, please just follow what I'm going to do on the URL here. So the first step here is to install Unbound. And to do that, you'll just run this command, pkg install Unbound. I've already done it, so it doesn't provide any more information. And the command you see here, pkg install, it's specific to the OS we're using, BSD. If it was Ubuntu, it would be something like apt-get install Unbound or similar. But once you install it, the instructions don't really change much in terms of once you have Unbound installed. They don't really change much. Ubuntu uses, Unbound uses a set of commands that will automatically configure some configuration for you. This step here, if you want to remotely control your Unbound instance, which you're going to see, and what it allows you to do is you can check information like how much information has been stored in the cache, how many requests have been done, and the status and so on. You can configure this, which is called a bound control setup. Allows you to do a bit of remote configuration on your Unbound installation. So as I mentioned, and I hope the font is okay for you guys, because I can't really tell, but let me do this. So the VM you have has three network interfaces. There's this EM0, which sort of, if you are working in an office, there'll be an interface that is connected to the rest of the LAN. That would have an IP address 192.168 or something. So that's what is on this interface. Then it has its own loopback interface, which is 127.0.200. Now, normally this would be 127.0.0.1 as your loopback interface, but because this is the it's like a virtual lab, we need to share the IP addresses. So each VM has its own loopback address. So a loopback can be anything within the 127/8 range. So once you know your IP addresses, we are going to configure Unbound itself. To do that, you have to go to the Unbound directory here. And by default, you'll see that there's an unbound.conf file. Now, for those of you who are, I don't know, I don't have the backgrounds of all the guys in the tutorial at the moment. If you're familiar with Unix and Linux, you'll know most services will have a configuration file that is called something.conf. So for Unbound, it's called unbound.conf. If it was Apache, which is a web server, it would be apache.conf. If it's Squid, it will be squid.conf, whatever it's going to be. But it's just a configuration file that allows you to configure your, the software that you want to use or the service you want to deploy. We're going to move the default file because we want to change what's on the default file there. So when you run that command, this tells Unbound to move the default configuration and change it to something like, to another name so that we don't conflict. And then we are going to open, we are going to fetch a pre-configured Unbound file. For those of you who don't have a lab, let me just share, well, it's the same thing, but what is in that file is what you see here, okay? And these are the configurations that Unbound needs to start, and I'll go through them one by one. For the rest, I hope you're going okay with the lab. If you have any challenges, you can just post on the chat. So verbosity one means you want to see information about what Unbound is doing. Verbose means show me more detail about what's going on in terms of logging. Okay. Statistics interval is how long the Unbound software will give you statistics, and it's going to we say dump statistics or display statistics, or we'll say dump because it's going to throw them in this log file here. And you'll see statistics like so-and-so has made a request and this was the answer they got. This interface here and this interface here, you have to configure your IP address. So YYY means you have to change your IP address. I know mine is 200, so I'm going to change mine to 200 here. And because this is a live lab, I can see there's a bit of latency. So yeah, we're all accessing the same URL and same server that's trying to virtualize this. Okay, so this is for my local area network. So if I was in an office, this would be the interface that's facing the office or facing my clients and so on. If it was an ISP, this would be a public interface that's facing my customers. Loopback interface, this is just for the host name, host device itself. You don't even need to necessarily use this if you already have this, for example. Access control, these are very important because what you're saying here is who is allowed to use this DNS server, okay? Loopback means anything that's on the loopback can access your DNS server. But if you are in a LAN, you might want to restrict maybe this server to a certain part of your local area network. So you'd specify it here. If you're an ISP and you're providing a DNS server, you probably don't want an open DNS server, which anyone on the internet can use. So you would limit this IP block range to whatever your customers are, okay? So if you have several blocks of V4 space, V6 space, you'd limit that then. Say access control, the only guys who can access this server have this IP address. I don't have access to the log. Sorry, I'm not seeing the chat. Okay, good. Thanks everyone for helping out. So the log file is where we're going to see the logs of the request being made. And we're saying we want to log all the queries and we want to log all the replies. And this remote control here, as I mentioned, it's optional. If you're using Unbound, it's nice to have just so that you can call specific commands from command line. You can see specific information about DNS. You don't have to do it, but I just included it there if you'd want to have this for your DNS server itself. So once you're done, you save the configuration file. Then I'll come back here and you'll just see what I'm doing.
Sorry, Kevin.
Yeah.
So maybe you can just explain how you're using the EE editor, maybe just how to save the file.
Okay. So there's a very simple text editor that's called EE, and it is almost like a what you see is what you get editor, almost in terms of the command line scenario. So you can use your arrows to go up the file or go down the file or go across. And this is what you'd use to edit the file. Now, there are other editors on Unix and Linux, there's several, but we're just going to use EE because I think for beginners, it's simplest. But if you're familiar with VI, VI is installed by default, you can also use VI. So very simple, you just go up and down, you make the change that you want, make sure there are no spaces when you add your IP address. And then when you're done, you press escape. So I'll just make the change. When you're done editing, you press escape. It will ask you, do you want to leave the editor? You want to leave the editor, so you press enter. And then it's going to ask you, do you want to save your changes? And yes, we want to save our changes, press enter. When you're done, it takes you back to the command line. At that point, we are now then ready to start Unbound. So for BSD, you need to run this command first, which tells...
Kevin.
Yes.
Just a quick question.
Sure.
The editor.
Yeah.
Is it across all editors that I can, for example, I've saved my IP whereby I escape, press ::WQ. Can that apply?
That would work on EE. That one will work on VI only.
So in this case?
So in this case, you'll press escape. So you've done it, you're done editing your file.
Yeah.
Yeah, so when you're done, so let's say like me, I'm done, I'll press a space here. You press escape. It'll bring up a new menu like this. You see that?
Yeah.
Then it's asking you, do you want to leave the editor? You press enter.
All right.
And then it's asking you to save the change. You say yes. You just press enter again.
All right. Thank you.
Sure. Okay, so I'm hoping you're all keeping up with the lab. Then once you're done with that, configuring your unbound.conf, the next step is to inform the OS that it needs to start unbound, or if the operating system was to reboot, you want unbound start in case the VM restarts or something. And you do that by using this command, sysrc unbound underscore enable equals yes. Okay. Then it's always good to check your configuration file. If you have made any mistake, like there's a typo or you didn't place your IP addresses correctly, this command, sudo space unbound dash check conf, will check the configuration file for you. It should report no errors. If there's an error, you need to fix it. Otherwise, unbound won't start. Okay. So once you're done with that, you can start unbound. You'll just say sudo service unbound start. Did I paste that? Okay, type it. Mine will complain because it's already working. So I'll say, sorry, copied it twice. So this graphical or rather web-based shell, sometimes it has a bit of latency, especially when there are many people using at the same time. So you may see a bit of latency as you do this. So mine is saying unbound is already running, so I'll just say restart because I have new configs running. And you should see starting unbound. And if you run sudo unbound control status, you should get a bit more information about your unbound. It's telling you it's version 1.11. I'm running an old unbound. There's actually now 1.15, but this is okay for test purposes. And a bit more information of how it's running. And the best way to know if it's running is using the dig command. So before I go to that, let me just see if there are any questions. Is everyone happy with the lab? Are you going on okay with configuring it? Hezron, you'll tell me on the chat if the guys are having issues. Let me see.
Yeah.
So
sure,
far, no
sure.
issues.
Lab complete, yes. Okay, good.
That's nice. That's nice.
Okay, so the simple way to know if your server is working is to actually ask it for some information. To do that is we use the command or the tool called dig. Dig, if you're not familiar with dig, it's a command line tool that allows you to interrogate a DNS server. If you're on Windows, you've probably come across, across NSLOOKUP or host. So dig does the same thing, but it gives you a bit more information about the server that requested, the time it took, and so on. So if you get this type of answer, it means your DNS server is working. The best, the line that you really want to see is this one because it tells you which server was used to obtain this answer. Okay, so how are people doing? Did that work for the guys? Are you able to query your DNS server? And if you're not, you can let us know. Then we try and debug, what may be wrong with your server. Anyone not having a working DNS server right now? Maybe that's the first place to start. The bit on fetching pre-config and config. Please do a recap. Okay, I'll do that. I also managed to get Google DNS going. Good. I'm getting server key file. User blah blah does not exist. Okay, Pius, we'll need to check yours. Maybe there's something you configure. Okay, so let me explain what I've done here. So step one is you install Unbound. Step two is to do it sets up the configuration keys between the remote control app on Unbound to allow you to do a couple of remote configurations. You don't have to do it, but I just thought it would be nice for you to see. Got mine to work after fixing an error. That's very good, Cynthia. So this step here, I was asking you to look at your IP addresses because you need to know which IP addresses are on your system, okay? Mine is working too, okay, good. Then the next step here is when you install Unbound, it goes to a directory, user local etc Unbound, okay? Unbound comes with a default configuration file. It's very long. I don't know if I deleted mine. Got Unbound. No, I think I deleted mine. Yeah, this is the default Unbound file. These are wrong to use. Let me use. So the default Unbound configuration file is very long, okay? So it has a lot of features, yeah? And, you know, I would advise you after this, have a look at it and see. There are several knobs and switches you can turn on and turn off depending on how you want to provide your DNS service. But for the purposes of this tutorial, since we're just doing the basic DNS, what I provided is a simple shortened version of the configuration file. So for us to use that, we have to remove or delete or move the default configuration file, and then so that we can use yours. So this command mv move says move this file and give it a new name, unbound.conf.original, okay? And then if you go to this URL, you'll see I provided a default or pre-configured Unbound file, okay? And when you fetch, this fetch is download, okay? Because we don't have a mouse and keyboard when you're doing command line, you have to use these commands to fetch files and so on. So fetch means fetch that file that is there, and what is on that URL, if you go to this URL, you'll see it is the contents here that I'm displaying here, okay? Then all you need to do is change this to match your IP address. Then when you're done, you'll save the file, escape, blah, 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 as you've seen. And then these commands here to start Unbound. And then finally, you start interrogating your DNS server. And basically that's it, your DNS server is working. In case you get an error, you know, maybe you can troubleshoot after the tutorial, but let me just go through a few more commands. Since you have dig, which is one of the tools you want to use, I think you should be able to dig my DNS server. So I think you should be able to dig, what did I allow? Yeah, if your DNS server did not work for any reason, you can use dig. Just say dig and my command and my IP address, which is 200. Okay, so let's just proceed, and we shall assume that everyone's DNS server is working. So to use the dig file, the dig command, you'd say dig at 192.168.2.200. That is mine. You can use yours. And if your DNS server is working, it should give you an answer section. And you can see some of the status messages here that it's working, okay? And you should see this. I will pick, I don't know who's on the lab that's working, but if I request my server for a non-existent domain, this is the NX domain I was talking about earlier, okay? So the key thing that you want to make sure is that your server is giving some sort of response, okay? Now we're going to use dig, but before we do, I'll just go back to the slides a bit. And can you guys see my screen?
Yes.
Yes, yes, yes.
Okay. So the dig command allows us to interrogate DNS servers on the net, okay? And you can ask for specific queries and specific information on specific resource records out there. When you do a dig, it's always recommended that when you type the host name or the resource, you know, the domain that you're looking for, always add a dot at the end. It will prevent any sort of additional information being added to the domain that you're looking for. Depending on how your operating system has been configured, some of them are configured to say that if I type www.finance, okay, it will automatically complete www.finance and append the rest of my domain. And that helps it, that helps you as, that helps the OS But when you're troubleshooting DNS, it can be a problem because you'll wonder what answer did I actually get? Did I get for my domain or did I get something that's actually on the internet? Okay. When you use dig, it formats the output in the following format. You've already seen it on your command line on your VM. It'll give you a status, either no error or NX domain or server fail. It will give you a few flags, recursion requested, authoritative answer. We're going to talk about that. It gives also this, which is a TTL or a time to live. Okay. And then it also tells you how long it took to make the request and the IP address of the server that responded, or the DNS server that responded, which in your case should be your DNS server. Now let's quickly look at those status messages. So there is no error, meaning the request went on through. NX domain, those domain, whatever you asked for does not exist. Server fail means there's something wrong with the server, it's not working well. Refused means you're not allowed to use that server. Okay, and there are several flags out there, not really important, but these are part of the DNS response. They are important when you're trying to debug. Maybe if your customers tell you, I can't reach your domain, I can't reach your domain. This is what you use to troubleshoot the problem. But in normal instances, you're not really going to interrogate that answer. So the output of dig, there's an answer section, as I mentioned. There's an authority section, which is the name servers. There's an additional section, which is more information about the DNS. It's the query time, and always check which server gave you the response. Okay. There's another short exercise which will help you understand the DNS output that you'll see on dig. Let me just copy this. And we'll do it with you on the command line as well. So I go back to my VM. If you go there, you'll see very simple dig commands that you can run, and then you can establish how your server is working and how, what type of responses it's receiving. So I'll go to that URL myself.
Kevin?
Yeah.
We have a question from Jeremiah who was asking, what is the remote control section for in the config file? Maybe you can just
okay. Yes.
touch on that.
Yes. So the remote control section allows you to do stuff like sudo. So it allows you to do this type of commands to get information about your DNS server and exactly what it's doing. And if you don't configure the remote control section, you can't do this. You can't get this type of information. Now, imagine you're at an ISP and you're providing, several DNS servers to your clients that they can use. Maybe you have 3 or 4. Most ISPs will have at least 2 DNS servers that you can use to query. If you're in charge of those and you just want to get quick stats, this is what the remote control allows you to do. So you can, do a dig, check the stats. You can check whether the service is running, and the other things you can do. It allows you to remotely run some commands against your unbound installation. I hope that answers your question there. Okay, so back to the second exercise, a very short exercise. What this allows you to do is just query your DNS server, see the different type of data you get back. So for example, if I want to dig and find out an A record, if we go back to my URL here. So I get the answer section is an A record, and this is the IP address, and this is the time to live, TTL. The time to live is configured by the owner of a domain. And basically what it says is that it tells all the caching servers, store that information for this amount of seconds, okay? If I do another dig for the same, you'll see the countdown has gone lower, okay? I'll do another one so you can see. You see the timer going down? So that timer going down is a time to live. And basically what happens is when that timer reaches 0, the caching name server will be forced to do a new request and get fresh information about that domain. Based on what you had mentioned, so I see a question, based on what you had mentioned on DNS cache, how can one detect or mitigate from cache poisoning attacks in their home office DNS resolver like the one we have built in Unbound? Okay, so for DNS cache poisoning, maybe I can just give some background for those who may not be familiar with DNS cache poisoning. So you can see this information counting down on my timer, okay? This data has been cached or stored on the hard disk of my server here, and it's being accessed by the DNS server here that you're seeing. Basically what that means is for as long as this counter is more than 0, your DNS server will not go out to the internet to find more information, okay? Now that cache, there have been attacks that try to alter the information that has been stored in your cache. Let me give you an example. So I'm trying to dig here KeNOG.org.ke and I'm getting this answer, okay? There are ways to, that malicious users can manipulate this information so that the IP address that you get directs you to another server that will try to collect your information. For example, let's say I have a website, bank.com or bank.co.ke, and I know everyone in Nairobi is, like there are several bank.co.ke customers in Nairobi, okay? So I know that everyone is doing online banking. So what I can try to do is if I want to collect everyone's usernames for the bank website, if only I could alter the DNS information they receive, I can create a dummy or a fake bank.co.ke website. And when everyone comes there, it will look like bank.co.ke, but it's a fake website that's only there to collect people's credentials, okay? That type of attack is, comes across when your cache is poisoned and the wrong information is stored. And your users, because they're not able to validate that information, they trust the information they got from the DNS and they go to that fake website and then lose their credentials. And once you have someone's credentials, so many other things you can do. So how do you mitigate against that type of attack? You can mitigate it. Well, one thing is to control who is using your DNS server. If I go back to the exercise here, maybe I can make this big. This access control will limit who can access your server, okay? There are, I'm sure you guys have interacted with the open DNS servers on the internet, like Code 8, Code 9, and so on. Those open DNS servers can be accessed by anyone, okay? But if you're just in your home network or you're a small ISP, you should limit your DNS service to only your customers or your clients. Now, as an extra security, you can implement validation, okay? And what validation does is that it verifies, it adds an extra layer of security that is inbuilt into your DNS server. And what your DNS server will do is when it receives information about a certain resource record, it will validate that record cryptographically using methods describing extended DNS. Unfortunately, we won't go into DNS or extended DNS. But what DNSSEC does and what extended DNS allows you to do is cryptographically sign information about your domain. And that cryptographic information can be verified by a DNS server, so that if you say that www.kenog.org.ke is this IP address, I am going to use cryptographic methods to verify that that information is correct. And that is one way of protecting yourself from DNS cache poisoning attacks. But that can only work if all of us implement DNSSEC in your domains or in your zones. So to give you an example, and I hope you guys are keeping track, I'm jumping from one window to another, but I'll just maybe show you an example here. So when I say dig DNS, I think .k should even work. Yeah, here we go. So .ke has been signed with DNSSEC. We won't go far into DNSSEC because it is a very big topic which takes a number of days to cover. And if I get into it, I might lose the, those who are sort of just coming to DNS. But what DNSSEC allows you to do is cryptographically validate the information that you receive on DNS, okay? Now, .ke has been cryptographically signed. So if you're here and you're a .ke, you have a .ke domain or .ke zone, .ke have signed one level of DNS, okay? But we have to create what's called a chain of trust. And that means if you're running kevin.co.ke, you must cryptographically sign kevin.co.ke, okay? And what that will allow is that for those people who are using validating DNS servers, they can verify that when I type www.kevin.co.ke, the resource record that I get is genuine and has not been tampered with and is not fake. And that protects me from going to an incorrect DNS server. So I won't go far into DNS, but I'll just show you, sorry, to DNSSEC, but I'll just show you one other test you can see how DNS works. DNS trust, let's see, okay. So when you use dig plus trace, and you can try this also on your command line, dig plus trace, it shows you the iterative step-by-step querying that a DNS server will do, okay? So remember when I was speaking with the slides, I showed you that the first query goes to the root servers. We have 13 root servers. They're labeled from A to M, A, B, C, D to M. There are 13 root servers. This is where the first DNS query will start, okay? So the DNS root servers also are signed, and this is a signature or a resource record signature. You can see it's a sort of cryptographic stamp, and that shows you that the root or the dot has been cryptographically signed, okay? And you can query and verify, and using Unbound, validate that this is actually correct, okay? Now, when we've asked these root servers here for KeNOG.k, they give us a referral. They say, okay, you're looking for KeNOG.k. We don't have the resource record that you're looking for, but we can direct you to the servers that are in charge, or the authoritative name servers that are responsible for KeNOG.k. And this is the second in the line here, okay? And then finally, these servers will tell you, okay, you're looking for www.kenitor.k. You want to ask these other guys because they're the ones who have the answer, and then eventually you get your answer. Okay, let me just demonstrate with the KeNOG.k website as well, no, which is a nice long one. I don't know if this will work well. Let's see. I don't know how many levels of referrals we will get, but let's see. So again, the first query goes to the root servers. The root servers give us a referral to the KeNIC name servers. KeNIC name servers refer us to the name servers for Safaricom, and finally you will get the answer that you're looking for. What did I look for, by the way? Yeah, ask for the name server. So maybe I should ask for an A record. Maybe you'll see that better. So let me ask for an A record instead to make more sense. So again, first query goes to the root servers. Root servers point you to KeNIC servers. KeNIC servers point you to Safaricom servers. Finally, you get your IP address information. Let me see if there's any question. Does that add override to my request and affect browsing speeds? Which part, Sam? Sorry, maybe you could elaborate.
Yeah. So Kevin, there was also another question.
Yeah.
And they were asking, once the TTL is 0, does it mean it has to fetch the record again from the authoritative server?
That is correct.
Yes. I think Sam has updated this question, adding the extra layer of security. So he's asking if by running DNSSEC, if it will add overhead to the overall browsing experience.
Yes, it does add a bit of overhead, but a tremendous amount of security. So the overhead is a small price to pay for the added security you get, especially if you're running data critical service, bank information, personal identifying information. If you have that and you're directing users to a service where they could get exposed or critical information lost, you really need to consider DNSSEC. If DNSSEC is a topic requested a lot by the community, we can do more extensive training on DNSSEC. It's not difficult to sign your records and add the DS records and the RRC records to DNS. That's not the problem. The problem is just maintaining that information. But it's a small price to pay in terms of the overhead, and you get the reward of increased security and mitigation from attacks that could cost you a lot of money. I mean, if you're a bank and your customers are directed to the wrong website, you can imagine what sort of damage can be done there. Credentials lost, money transferred, and that type of thing. So it's not if you should do DNSSEC, it's a matter of how soon can you implement it if you've not done it already. The big providers are already doing it, and it's an extra level of security. So the trace command is dig plus trace. Yeah, and thanks, Amanjit, for that as well. So I'm looking at the time. There are more slides to cover, but I don't think we'll cover those. I think we've done the DNS interrogation part. The only thing probably you'll need to understand, I think this slide is very important. So now that your DNS servers are working, I've shown you how the DNS plus trace works in terms of you will start with the root servers, the 13 root servers, you'll get a referral. The referral will point you to, if you're doing .ke, they'll point you to KeNOG. So as you can see here, KeNOG is very important to us in this .ke world in Kenya. KeNOG, they've done the DNS signing. They have several DNS servers available as backup. So not even if one KeNOG server goes down, we have several others that are available, some of which are outside the country. So we didn't get to talk about redundancy, but when the day we'll do the authoritative name servers, you will come to see that it's important. In fact, it's required that you have more than one authoritative name server that can give referrals or give answers, okay? Then finally, you'll get your answer. So if this was an empty cache, this is what you would see. But once your cache server works, your cache server just gives a direct answer immediately. It's stored on the disk. And the best way to display that is, if I go back to my shell here, if I say dig at my server 192.168.2.200, let's say I dig for something I know I've not looked for before. Let's say soccer.com. You'll see the query time is 170 milliseconds. Okay, that's how long it took to get that answer. But if I do that again, you see the query time has dropped. Okay, because now that answer has been served in the cache. Okay, and in fact, it should be 0 milliseconds all the time once it's stored on the cache. The reason you see 9 milliseconds here is because we're in a virtual environment. We have like this where your labs are provided. We have more than 100 VMs running there. So there's a bit of delay, latency in that, but you should always, once it's cached, you should expect 0 or close to response. And this shows you that your caching server is working, okay? And as I mentioned, the time to live is provided by whoever is in charge of soccer.com. So when this timer gets to 0, my caching name server, resolving server has to go back to the root system and start that process all again to get the answer. Now, if you're in an office, let's say you're in an office environment or you're at home, you have 10, 20 users, this doesn't happen all the time. So the first guy who comes in the office and types kenog.org.ke or nog.ke, the cache will store that information. So the next response will be much faster. Okay. So please could you share the PPT slides? Yes, I'll share the slides on email. So to wrap up, just for you to understand, why would you want to do this, setting up your own server? You get a much faster response time. You can control who has access to information. When you use an open DNS server, your ISP's DNS server, they can see all type of queries that you're doing. And there's one command I think you can look at your log file. I'll share the command so that you see what's on your log file. Sorry, my bad.
Sorry, I think you've typed two commands. It's tail -f, then cd. Yeah.
There's a bit of delay because of the environment. But
okay.
There you go. Log. So
yes, I think.
So this is just a log file, and you can see it shows you information about the domain that was requested, queries, and the status. So if you're an ISP, you can easily tell information about your clients. I can tell all my customers are requesting this, or this client went from this website or requested this service, and so on. So when you have your own DNS, you increase the privacy. I'm not saying that once you do your own DNS, it's impossible for other people to determine what you're doing. It's not impossible because your IP address, your routing will display information, IP address, so on. But you get that one bit, one more level of privacy about your information, okay? Because this log file is available to your provider. Now, we didn't get to talk about DNS over HTTPS, which is a new, well, let me not say new, but let me say it's a growing way of increasing the privacy of DNS. We didn't talk about DOT, DNS over TLS, which is another level of security of hiding what you're trying to do on DNS. But perhaps you can do that at another time. So I think because I'm looking at the time, I'm going to give one other round of questions. I hope all of you are able to get your DNS servers working. Those of you who had labs going. Can the VMs reach each other? Yes, you should be able to ping. Someone else could try to, yes, you can use 200. Yeah,
sorry, Kevin, maybe just to, on the question of about security, about man-in-the-middle attack.
Yeah.
Sorry, for cache poisoning, I think also it is important for guys to be aware that when you're running any service out there, it is important for you to ensure that you are running services, packages or software that is stable and released, that is recently released, because one of the biggest problems that you might find when it comes to things like cache poisoning is that you might be running an extremely old version of the software, which of course has vulnerabilities that people can exploit.
That's true. Thanks, Sergeant. That's correct. So someone was asking if another server can access 200. So you can access it. You can ask any query on it. And so this is another IP 110. And I get the information about the IP that requested the resource record and which resource record was requested for, the type of record, a record, and what the status was. Okay. And I can see 2.91 also is requesting for, okay, I don't know which made, but anyone can reach the 201. So you can see queries. So what I was saying is, when you use someone else's DNS, when you use the open DNSs, when you use your ISP's DNS, that information is available to them. So they can tell which websites you're going to. Sorry for those who didn't know that, but a lot of that information is available. You can add a level of privacy by doing your own DNS. You can add another level of privacy if you do DNS over HTTPS, DNS over TLS, which we didn't cover, but it's, and you can do DNS over HTTPS using Unbound, and I've tested it. It works well, adds another layer of privacy, and it's something you can consider. And once you deploy these services, they are really fire and forget. You'll rarely need to especially for a small home office, you'll rarely need to come and look after this thing because it just manages itself and it's not really resource heavy. And it's something you can deploy even right now, as you've seen. Just a few commands, you have a DNS server that's running. So yeah, let me see if are there any other questions? Yeah, so I see 2.91 has requested Google.com. So I hope that clarifies that information about the log file. Okay, if there are no other questions, I think we can stop here. Looking at the time, we tried to limit it to 1.5 hours max. We started about maybe 2:05, so we're just coming up to that. Any other questions or clarifications on DNS that you'd like to make?
Kevin, maybe from my side, I'd like to say thank you for this presentation. I'm actually very interested in the DNS over HTTP and TLS. So I look forward to that session.
Okay.
Thank you.
Okay, sure. Thank you. So we'll discuss and see, I don't know which one comes first. I don't know if it's DNS over HTTPS or authoritative DNS. So we'll see. But we'll discuss with the KeNOG PC. And also thank you everyone for joining, because we've now seen that the lab works quite well. And there was a bit of latency, but not so bad. So that was also good to see. So yeah, maybe next time we can do something.
Kevin, just one thing,
Yeah.
how are we going to measure the success of this tutorial? And I think this is a question to participants. Can we have guys running some DNSs in the networks? And then we get like probably some feedback on the community list and the WhatsApp chat. I think there's been some discussion a week ago whereby people are asking why are people sticking to cloud providers like Cloudflare, Google 8.8.8.8. So I think this is the to run such things in your networks, at home, office, and wherever.
Yeah, that's true. I mean, it would be good to see more people deploying this very simple service. Whether you don't even have to be like a hardcore engineer to do this anymore. They are very easy, especially on things like Ubuntu. They automate a lot of the configuration for you. And this is a very light resource to manage. I mean, with 128 MB to 56 MB RAM, that will easily serve a small office. So it would be good to see more people deploying this. And now that, I'm hoping people have understood the roles of DNS and, configuring this, the next level is how you manage your own authoritative DNS. So let's say you want to go to KeNOG and pay for blah, blah, blah.co.ke. Now you could be able to understand a bit of the infrastructure behind that and how to do it. And, there's, as I mentioned, this this training is part of a much longer training that we do. Eventually, we build this all the way to where you're deploying your email system. Your email cannot work without DNS. So it goes all the way, it sort of builds its way up. So it's unfortunate this year we couldn't have a physical workshop. Hopefully next year we'll be able to do one as KeNOG, and then we can deploy. But Simon is right, it would be good to see more people deploy this services. Is it possible to get a recording? Yes, or I've been recording, or I hope it's recorded. So yeah, I'll share the recording of this. Okay, thanks everyone. So I think we can stop here. I'll share the slides and the recording on email. Thanks for joining.